Hey there, students. So I wanted to talk about 3D trig in this assignment. And you can see here what I'm talking about, that this is a three-dimensional object. It's like a box, or the British call it a cuboid. I would call it a rectangular prism. I guess I should write those. And I only mentioned the British because the exam is IGCSE. It's a British exam. They call it a cuboid. I would call it a rectangular prism, or in layman's terms, just a box. So cool. But the key is that it is a three-dimensional object. So here we have a three-dimensional object, and we're going to need to apply some trig to it to do whatever it is that they've asked us to do. So let's look at what they're asking us to do. Diagram represents a room which has the shape of a cuboid. Oh, they say it there. AB is 6, they already marked it. AD is 4, they already marked it. And AP is 2 meters, and they already marked it. We want to calculate the angle between diagonal BS and the floor ABCD. So I'm all about drawing these things first. Maybe well, it doesn't matter. Okay, diagonal BS. So if I'm looking for diagonal BS, I think we're going to connect B and S. And I can see what they're saying. That's a diagonal going all the way across the box. So just to note, like, I don't know if this helps, but if you have trouble visualizing it, this would be like in front. Oh, how do I send that to the front? I don't know how. Oh yeah, good. That would be like in front. This diagonal is going through the box, like through the center of the room. Cool. And we want the angle between that and the floor ABCD. So when I think of this floor ABCD, well, that's ABCD. That's like the whole floor, the base here. So the angle between that plane and this segment is going to be like this angle in here. So I'll go ahead and mark that. This angle I will call theta. I could just call it X or whatever, but I will call it theta. Great, so we got angle theta, that's what we want to find. And just because it's pretty clear to me we're going to use this, I'm going to go ahead and draw this in. So I'm a big fan of, whenever I have a 3D trig, I actually take these things and I draw the two-dimensional triangles that we've got. So we've got this triangle. We know this is 90 degrees. This is angle theta. This is B. This is S. And this is D. So I'm just pulling that red triangle out and actually drawing it here. Then if I knew any side lengths, I would go ahead and label them, and I do actually. This is 2 meters, so this here has to be 2 meters, so this is 2 meters. Great, to find that angle, we're almost like halfway, because you know with trig, we only need 2 sides of this triangle and we could find that angle. But we don't have a second side here. I don't know how long these diagonal pieces are, like the diagonal across the floor and the diagonal from the bottom corner to the top corner of the room. I don't know what those lengths are. So now I need another triangle that I can use to find one of those lengths. The one that I see is, I know this is 6, I know this is 4, and that means I could use trig or the Pythagorean theorem to find this side here. So, okay, I'm a big fan of, I always take these triangles out and draw them. So we've got this other triangle now. It is going to look really similar just because of the way I'm drawing them, but those triangles are definitely not the same. So this triangle is a right triangle. This is D, this is A, and this is B. And the thing that is nice to notice is that here we have DB, I'll call it X, and here we have DB. So I'll label that as X as well, because those two sides are the same. This is DB, this is also DB. And it makes sense, like they're both this side here. So cool. Then, yeah, we have other sides here. I know that the DA is 4. I know that AB is 6. So I could use trigonometry and like find one of these angles and then use it to find the third side. I can also just Pythagorean theorem this, because we have a right angle. I know that Pythagorean theorem, like a squared plus b squared equals c squared, works in right triangles. So I'm just going to start with 4 squared plus 6 squared equals x squared. And that's 16 and 36, 36, 46, 52, so 52. And then I'm going to have to square root that to find what x is. Since we're IGCSE class, I'll go ahead and pull out my scientific calculator. if my computer wants to do things. Cool, scientific calculator. We want 52 square root. I'll just say 7.21. So x is approximately 7.21. So over here, this is, well, I could just use square root 52, but it's also approximately 7.21. So either of those are options for me to use for that side length. And then we want to find this angle. Well, now I'm just going, okay, from this angle, I know this side is opposite. This is the hypotenuse, so this side is adjacent. And then I would look at my SOHCAHTOA. You will probably go a bit faster through this part because you have a lot of practice, but I'm just trying to say, like, this is every step I would think. So then I've got opposite and adjacent. I see opposite and adjacent, so I'm going to use tangent. So I would think tangent of our angle theta, and this is the angle we wanted, the diagonal BS and the floor, that's this angle, that's the angle we're looking at. So good, this is what we want to find. That's our objective in the whole question. And tangent is opposite over adjacent, so I would get 2 over either the square root of 52 or 7.21. Doesn't matter. Most of you will be more comfortable probably taking the 7.21. Good, so then I know this angle is inverse tangent, tan inverse of this ratio, 2 over 7.21 or square root of 52. And so let's get that calculator back out. 2 over 7.21 is what? And then second inverse tangent. I get 15.5 degrees. So this should be 15.5 degrees, and that is the angle they asked us for. As a last piece, I'd say, what if we use square root of 52? So I would do 2 divided by parentheses 52 square root, and then I can see I'm doing 2 divided by square root of 52. Great, so that equals 0.277, and then inverse tangent. And I get that 15.5 degrees. So either way, we get the exact same answer at the 10th place of the decimal, and that's perfect. That's exactly what we want. So great. Here's what I've tried to convey here. We're talking about 3-dimensional objects, and we're going to apply trigonometry to it. But our trigonometry ideas are only 2 dimensions. Like, these are 2-dimensional triangles. This is a 3-dimensional cuboid or rectangular prism. So we have to visualize what it is we want. Draw the 2-dimensional pieces that will allow us to resolve whatever it is they asked for, and then use those 2-dimensional pieces to actually go and solve the problem. So I hope this makes sense. Let me know if you want to discuss anything, and best of luck. Talk to you guys in a bit.